So this is a video on 6.2, and so we'll see how we go on it. It's about function notation, and using function notation you're going to see that it's very much like substitution, and I like to use the parentheses. If you don't use the parentheses, you'll likely get them wrong. So use those parentheses. Hi, welcome back. We're going to look at 6.2. It's on function notation. This is the name, the generic name for the function f. At x or of x, people would say. I like the word at better. And that's the generic name for the input value, an x value. And the whole symbol is the output value. And remember, our input was our x and our output was our y. And so this function notation it has both of those. It's going to have both of those in there. And so just so that you can kind of see down here at the bottom of the page that y equals x plus 1. So not a very fancy equation, but it ordered pair would look like if x is 2, 2 plus 1, y would be 3. In function notation, you would say f at x equals x plus 1, so that f of x is another way of saying y. And then you would say f at 2, and that's your ordered pair 2, equals your y value 3. It takes a little bit of time to get used to it, and those are the first problems that they have actually in your book, is just getting used to it. But it turns out to be a beautiful thing after you get used to it. And so here is problem 2 out of your book. Commonly on function notation that they'll show a little picture like this, where you're having your input go in, your function does whatever it's going to do to it, and then the output gets spit out. And so it is really like substitution. And so number 2 says here, f at 3. So we have two functions, f and g. And so we don't want to use the g function because this says to use the f function. And so we're going to replace in there 2 times x, I'm putting parentheses for x, minus 5. And what we're going to put inside those parentheses is they're saying that the input we're wanting to use is 3. They're saying our x is 3. So we're going to put in 3 there, and then we're just going to do the arithmetic. 2 times 3 is 6, minus 5 is 1. And so the whole thing together would look like this. F at 3 equals 1. In the back of the book, since they asked you what is f at 3, they'll just say 1 in the back of the book. G at 2, well, the g function squares, then adds 3 times it, and then adds 4. So this would be the blank squared, the parentheses squared, plus 3 times the parentheses plus 4, and we're going to be plugging in 2. And then we'll do the arithmetic, so that's 4 plus 6 plus 4 is 14. So the whole thing would be g at 2 equals 14, but in the back of the book, they're just going to put 14 since they asked you what it was. This is number 20 in your textbook, and number 20 is the difference on it, I guess, is that there's a fraction, but same idea. So 2 functions to consider, so I'll pick up the g one. That's 2 times my parentheses minus 1. And what am I going to put in there? The 1/4. And then I'm going to do the arithmetic. 2 times 1/4 minus 1. And of course, I'm free to do that on my calculator. 2 times 1/4 minus 1. I don't know if you can see my calculator screen. Almost you can, huh? And equals, and it's negative half. And so this is equal to negative 1/2. And that's what they're going to have in the back of the book, because that's what they were asking me about. If I wanted to say the whole thing, it's g at 1/4 equals negative 1/2. My function is a different function for f and g now, and they're on number 40. They're asking me to evaluate 1/3. And so I'm going to put that in here. So this is 1 over my parenthesis plus 1, and I'm going to put in 1/3. And I can certainly put that in my calculator or do that in my head, whatever you want to do. That part right there, 1 divided by 1/3, that part, 1 divided by 1/3, is the same as 1 times the reciprocal, 3. And so that's just 3. And so this is 3 plus 1 is 4. And so actually, on that one, I think that it's easier probably to do it by hand than it is to put it in your calculator. But if you wanted to put it in your calculator, you hit the fraction key and you put in the numerator 1. Then you go downstairs and you want a fraction. Now you can put parentheses if you wanted, and you want a fraction, and so I'll fill in 1/3 and then into parentheses. And then I want to go out to the side here. Woo, I went too far. And so that I can put my plus right there, 1. And so now I put it in just like I see it, and it gave me 4, the same thing that I got when I did it by hand. Okay, so this is the next one here is number 34. And they have a little bit of addition there. They say find f at -1 and add that with g at -2. Now f at -1 is just going to be a number, and I can find that number off to the side if I like. I think I will do that. F at -1 will equal squared minus 2 times it, right? So put in -1 there. And so that f at -1 will equal, and you can put that in your calculator or you could do it with your head. That's 1, and then negative times a negative is a positive. 1 plus 2 is 3. So this is 3. So right here where I have f at -1, I'm going to put 3. And I'm going to add that with whatever I get for g at 2. So this is like my little side piece of paper. G at -2 is 5 times the blank minus 4. So I'm going to put in -2. So I'm going to get -10, take away 4, which is -14. Also can do it on your calculator. So plus -14. I'd be tempted to put some parentheses around the negative number there. And then you would add those together. So when you do, you get -11. Then 2 times f of x minus 3 times g of x. Now they didn't tell us a value to plug in for x, so we're not going to be able to plug a value in. But we do know that f of x equals x squared minus 2x. So this is saying 2 times, and I'm going to be substituting in what f of x is. X squared minus 2x. Minus 3 times, and I'm going to put parentheses because I'm going to substitute what g of x is, and that's 5x minus 4. Then I would use the distributive property here, and that's going to be 2x squared minus 4x, and then here, minus 15x plus 12. And I would combine like terms. So here in the center I have like terms, coincidentally they're in the center. 2x squared minus 19x plus 12. And that's my answer here. And so we did a good job on that one. I hope I haven't gone off the screen. I haven't, thank goodness. That can happen to me, as you already know. Okay, this one says f at 3 on the inside. So it's saying g at f at 3. And so the first thing you're going to do is you're going to work from the inside out, kind of like you would have with the order of operations. And so our first thought is to do f at 3. So that's my first thought, is f at 3. And so remember f squared and minus 2 times, right? So I'm just putting in, remembering what f is right here. There's f. And I just put for the blank, and I'm going to fill that in with 3. So when I do the work, f at 3 is 9 minus 6, which is 3. So that's what f at 3 is. So this is f at 3, right? So this is going to be g. And they use brackets. Oh, it's coincidentally 3 instead of parentheses, but it means the same thing. So this could have been, you could change this to parentheses if you wanted, g at 3. And so those brackets and those parentheses in this case don't mean anything different. And so this says go to the function called g, and substitute in for x 3 is what this notation says. So our function called g looked like this. Here's g. We're going to have g at 3 equals 5 times the blank minus 4, and you're filling in 3, and then you're going to do the arithmetic. 15 take away 4 is 11. So g at 3 is 11. So this whole thing, g at f at 3 is 11. So we did a lovely job on that page, and we're going to turn to the next page on 6.2. Okay, and I have to move it down so that you can see it. And here they have given my functions, instead of giving them as an equation, they've given my functions as ordered pairs. And so this is asking me to find g at 1. And what this says is, it says when x equals 1, what is y? That's basically what it's saying. So I don't want to be looking here for the function f. I want to look at the function g. And I want to look where I have an x value that's 1. And since it's a function, I should only have one of the x values being 1. So this x value is 1, that x value is -2, and that x value is half. And I'm only interested in the x value being 1, and it's asking me what is the output. Well, the output, the y value, is 1. And so g at 1 is 1. And that's my answer. Again, in the back of the book, they just simply put 1, since what they asked you about. Now here it's asking me to add. This is an example. It didn't come from the book, but it's asking me, I said add, but it's subtract. F at pi minus g at half. So I want to look at f. Here's f. And pi, so I have inputs 1, -2, and 3, and also pi. And the output for pi is 0. So f at pi, doing that part, is 0. And then minus g at half. Well, g at half is 0, coincidentally. And 0 minus 0 is 0. So our answer is 0. So we did a lovely job on that. And 58 has a step function. And it's from your book. It says figure 4 shows the graph of a step function C that was used to calculate a first-class postage on a letter weighing X ounces in 2006. Use the graph to answer the questions A through D. So in question A, they ask us to fill out the table. So how much would it cost you in cents to mail a letter that's 0.6 ounces is our first. So here's 1 ounce. So from 0 ounces, and of course 0 is open because you can't weigh something. And so a little more than 0. And so 0.6 is not quite 1 ounce. And so in 2006, that cost 39 cents. I'm making sure that everyone knows that this is 2006, and so that you don't try to mail anyone a letter, and because it's not going to go if you only put 39 cents on it, because now we're in 2020, so this is quite a long time ago. Okay, and so how much would it cost to mail a letter that weighs exactly 1 ounce? Well, exactly 1 ounce is also 39 cents because it's closed there. It's not 63 cents. If it's a little more than 1 ounce, that's when it's going to cost 63 cents. And that's what they ask you next, 1.1, which is a little more than 1, so that's 63 cents. And 2.5, so here's 2.5 is going to cost 87 cents. 3.0 is going to cost 87 cents as well. And 4.8 is going to cost $1.35, so 135 cents. 5 ounces is going to cost us also $1.35 or 135 cents. And 5.3 ounces is going to cost us $1.59. And so I hope that you're able to look those up at those prices. And then it says in part B, it says, if the letter costs 87 cents to melt, how much does it weigh? State your answer in words. State your answer as an inequality. State your answer in interval notation. So I must have added that on here, state your answer in interval notation, because we haven't done interval notation yet, and we don't do that until chapter 10, I think, whatever chapter it is. So stating my answer in words would be, so 87 cents, let's look here, 87 cents. It has to weigh more than 2 ounces and can weigh up to 3. So my letter, the letter would be more than 2 ounces and more than 2 ounces and less than or equal to 3 ounces. Now, those were our x values, if you will, on our x, right? And so to write this as an inequality, x is going to be between 2.0, and I don't want to put equal to 2.0. It had to be more than, otherwise we'd get to mail it for cheaper, and less than or equal to 3 ounces, all the way up into including 3 ounces. We can have our letter weighing. And so our x, if it's 87 cents, to mail it is between 2 ounces and 3.0 ounces, where it can be exactly 3.0. Okay, the next page has more questions based on this step function that we have. So I'm going to make sure that I get that on the screen. So I'm still looking at this grid here. I'm still looking at that grid to answer these questions. If the entire function is shown in figure 4, state the domain. So we're going to be looking at the domain, and so would you agree with me that the smallest x that we have is 0, but it doesn't include 0, so something just right after 0. So x is going to be between, well, did it leave 1 out? No, we have an output that goes with 1. Did it leave 2 out? No. 3 out? No. Didn't leave anything in between out, all the way to 6. So our domain is going to be from 0 all the way to 6 ounces, including 6 ounces, because 6 ounces wasn't open. So on 6 it wasn't open, so it included 6, where at 0 it was open. Okay, and then it says state the range. And this time the range isn't infinitely many values. Like, is there any letter under this scheme of melling that would cost 30 cents? No, it costs 39 cents, not 30. Is there any one that costs 50 cents? No, that's not a possibility. So the only possibilities, and I guess they've called the range C. So the range here we're going to call C. So C is our range, is going to equal, and it's going to be these values, and I'm going to use that set notation like I did back when we did the ordered pairs, right? So I only have outputs of 39, 63, 87. So 39, 63, 87, 111, 135, and 159. Those are the only possibilities for the cost for this step function that you would have. And so, and then I ended it with my set notation. Okay, so that was that step function that they have, and that takes us to the end of 6.2. I have